Okay, really quickly before we start, I want to go over some stuff we talked about Friday. Okay, you know how like when we're dealing with linear equations, it's y equals mx plus b. Well, when you're dealing with exponential equations, it's y equals a times b to the x power. Okay, you may even see it written as y equals b to the x power. When would you think it would be okay to just write the b and not write the a? If the a equals what? 1. Think about it. If the a was 0, 0 times that would cancel out the whole equation, right? But if the a was just a 1, is there any need to write 1 times something? No. So if you see an equation in this form, that's okay. It's still an exponential equation. It's just the a is not there because it's an understood 1. Okay, now, this would be for an exponential equation that crossed through the y-axis at 1 because the a value is 1. But you may have a horizontal shift. Now, say that I added 3 to this x. That's a horizontal shift. Which way does it shift? Left 3. Okay, say on the end I put a big -2. What kind of shift is that? Okay, look. If this is a horizontal shift, then this is a vertical shift. Okay, hold on one. Okay, so if the number up here with the exponent is a horizontal shift, then the number over here is a vertical shift. So like if it's plus k or minus k, that would be up or down. But if the k is with the exponent, that's either left or right. This is actually left and minus is actually right. Okay? On Friday, every one that we did had +0, +0, right? It didn't shift horizontal or vertical. And so the asymptote stayed at 0. But today we're going to start having shifts. Okay, so let's talk about what that means. Okay, number 3. All right, what is the a value? 1. Guys, remember, the b value is what's raised to the x, so b is 2. Now, is there going to be any kind of shift? What kind of shift? Up 1. That +1 means that it's going to shift up 1. No, it's only backwards when it's with the exponent. Okay, now let me show you something. The a is 1. So, originally, this curve would have crossed through the axis. This is important. If the a is 1, then originally this exponential curve would have crossed through the y-axis at 1. But because of this vertical shift, it's now going to cross through at 2. Okay, let me say that again. The a was 1. So, like, had this not been there at all, it would have crossed through at 1. But because there is a +1, it moves your y-intercept up 1 unit, which is now at 2. Now, even if you're not comfortable with how I just got that, you'll get that point eventually when you do your table of values. Okay, so remember, you can choose whatever x values you want. I just choose small x values so that I know it'll stay on the graph. I also choose some that are negative and some that are positive so that I can see what's going on with the curve over here and over here. Okay, so I'm going to use numbers like -3, -2, -1, 0, 1, 2, and 3. Okay, let's talk about how we're going to plug those in. All I'm going to do is plug in this equation, okay? See this equation on the board? 2 to the x plus 1. But in the x place, I'm going to plug in my first x value, which is -3. Okay, but don't forget plus 1. 2 to the x plus 1 equals 1.125. Okay, then I'm going to plug in my next x value. If you want to, you can just highlight it and copy it. And then all you've got to do is replace that 3 with a 2. And you get 1.25. Okay, then you plug a -1 into the x place. 2 raised to the negative 1 plus 1 equals 1.5. Now, the rest of them you can probably do without a calculator. If we plug in a 0, what's 2 to the 0? 1. Anything raised to the 0 power always equals 1, and then when we add 1 to that, we get a 2. Okay, what's 2 to the first power? Plus 1. What's 2 to the second power? Plus 1. And what's 2 to the third power? 8 plus 1, 9. Because 2 cubed is 8. Okay, now let's plot these points. I'm going to start with the whole numbers first. 3, 9. How do I get to 3, 9? Positive 3. Right 3. Up 9. Okay, 2, 5. How do I plot 2, 5? Right 2, up 5. How do I plot 1, 3? Okay, 0, 2. Look, it's already there because of what I did earlier. But had you not done that earlier, it would be fine. You would plot it now. Okay, negative 1, 1.5. How do I plot a point like that? Right. Okay, what about negative 2, 1.25? 1.25, yeah. So teeny bit lower than that one, which is kind of hard to tell because the graph's small. And then negative 3, 1.125 would be left 3, and then a little lower than that. So, do you see how on the left side of the curve they're starting to flatten out? And what are they all getting closer to? 1. Okay? And the reason that I could know that without the graph is because that lets me know the asymptote as well. Okay? So my asymptote is at 1. It'll never go below 1. Even if you plugged in like negative 15, it's still going to be 1 point something. Okay? Because that plus 1 shifted the entire curve up 1 unit, putting the asymptote at 1. Now, once you have your points, you can connect them. Okay, so when you hear domain, what do you think of? The x-axis. So this curve, like if you continue to follow it to the left, how long does it go to the left? Forever to the left, which is negative infinity. What about to the right? Positive infinity, because as it's going up, isn't it also slowly going to the right? So it goes from negative infinity to positive infinity. Let me go ahead and give you a heads up. All exponential functions have the same domain. They all have negative infinity to positive infinity. Okay, all exponential functions have this domain. Now, the range will change because the range is about the y-axis. And what causes that to change each time? The what? Well, right. So what would cause the range to be different on every one of them? Well, but even if it's decreasing, what is it that's keeping this curve from going down forever? The asymptote. So basically your range will go from the asymptote to infinity. Where is the asymptote? And then you can go up forever. Okay, now the behavior, is it increasing or decreasing? Increasing. It's a growth, right? And how could we have already known it was a growth before we ever put it on the graph? The b value is 2, and if your b value is greater than 1, it's a growth. Okay, where is it increasing from? Okay, look, this arrow means that it goes forever. So when did it start increasing? Negative infinity. And when does it quit increasing? Never. So positive infinity. That will always match whatever you put for the domain, which is always negative or positive infinity. Well, actually, wait one more and then you can go. Okay, number 5. Number 5. I know. All right. For number 5, what's the a value? 1. What's the b value? 2. Are there going to be any shifts? There's going to be a shift of left 1 because of this x plus 1. Because it's the invisible 1 right there. 1 times 2 to the x power. Okay, now, so if your a is 1, then originally, before any shifts occurred, your y-intercept was at 1. But where does that point move now that there's been a shift? Left 1, which will cause a different y-intercept also. Okay, now, is it going to be a growth or a decay? A growth. I'm about to split y'all up. A growth because your b value is greater than 1. Now, to get the rest of these points, we make an XY table, and we'll continue using those same values. I want the row that Eric's on towards me, you're going to plug in the negative x values. The row that Haley's on towards the wall, y'all plug in the positive x values. So all of y'all over there plug in the positives, all of you slackers plug in the negatives. You are. Let's continue. Okay, what did you get when you plugged in -3? 0.25. Okay, what about -2? 1. 0. 1. 2. And 3. Okay, when I get ready to start plotting these, I can see that 316 is not going to be really nice because it's going to go out the graph, so I'm just not going to plot it. Okay, 2, 8, over 2, up 8. 1, 4 would be over 1, up 1, 2, 3, 4. 0, 2, there's my y-intercept. -1, 1, there's that point I knew from doing the original y-intercept and shifting it left 1. And then -2, 1/2, -3, up 1/4. So these are all approaching where? 0. Our asymptote's at 0. Why is our asymptote still at 0 even though there was a shift? Right, it only shifted over. It didn't shift up or down, and that doesn't affect the asymptote when it only shifts left or right. Okay, what is the domain? Right. What is the range? And what is the behavior? Correct. Okay, I want you to take a few minutes and try 4 and 6 by yourself. Here we go. Number 4, what's the A value?
1.
Okay, the B value is 1/2. Is there going to be any kind of shift? What kind of shift? Down 1. Okay, so where's the y-intercept going to be? At 0, because originally the A being 1 told us to put it at 1, but if everything's getting shifted down 1, it goes down to 0. Okay, now I'm just going to use this chart again over here to do my XY table. I'm going to use the same numbers. So what did you get when you plugged in -3 into the equation? -2, -1, 0, 1.
Yeah, I thought it was doing it wrong.
-1/2, 2, and 3. Okay, so now I'm going to plot these. -3, 7 would be left 3, up 7. -2, 3 would be left 2, up 3. Turn around. -1, 1 would be left 1, up 1. 0, 0, we already plotted. 1, -1/2 would be right 1, down 1/2 a block. 2, down 3/4, and 3, down 7/8. So our asymptote is at -1, and you can see that from the equation because it's -1. Okay, the K value will tell you where your asymptote is. Okay, so what is the domain? negative to positive infinity. Remember, for exponential equations, they will all have a domain of negative to positive. Now, I know why some of you get confused because you want to call this positive because it's going up. We don't really care about up when we're talking about domain. We only care about left and right. So is this going left or right? Left, that's why it's negative. This side's going right, that's why it's positive. Okay, now range we care about up and down. How far down can you go? Negative 1. How far up can you go? Positive infinity. Okay, is it increasing or decreasing? Decreasing. From where to where? Right. Okay, now let's look at number 6. Okay, number 6. What's the a value?
So it's a 1.
1. Remember, this is always the b because it's raised to the x. So what kind of shifts are we going to have? Right to and up to. So I can go ahead and find my first point without even doing the table. If the a is 1 and I start at 1 but then I go right to, up to, I know I'm going to have a point right there. Okay, now to find the rest of my points, I'm going to use the table of values. Okay, y'all plug those in? What do you get when you plug in negative 3? 5. What do you get when you plug in negative 2? Negative 1. 0. 2.1. 1. 2. And 3. 37. I'm about to check them because it feels weird from what we're doing today. Okay, so 3 raised to the negative 3 minus 2. Oh, so look, the minus 2 has to be up there with the exponent. Then plus 2. So this should be 2.004.